Okay, today we are going to talk about the basics of polynomials, and we're going to go through a bunch of vocabulary and other things like that, so this might be a handy video for you to keep in mind if you wish to come back later to have any of your questions answered. So let's begin by talking about what a polynomial is. And you've probably already seen polynomials and just did not know the correct terms for them. But a polynomial is a mathematical expression involving a sum of powers in one or more variables that are multiplied by coefficients. Now this is a pretty technical definition, but if we break it down, here's how we can remember it. Poly means many. Noma is a way of ordering things, and EL means pertaining to or belonging to. So what this word really says is we've got many things that we're going to order that all belong together. And that's what a polynomial is. And we'll give you a better idea of how to identify polynomials in the upcoming slides. Let's first talk about monomials. Mono, or mon, from the Greek monos, means single. This is a one-term polynomial. It's an expression that you can write as a product of a non-zero number, which is called a coefficient, and one or more variables, each raised to a non-negative integer coefficient. Now, notice I said non-negative. We can have monomials that are multiplied by a zero power, and we'll see that here in a second. So here's some examples of monomials. 3x. 3x would be a monomial, because what we have with this is 3 times x to the 1 power, and that is what 3x is equal to. Okay, I'm going to get this a little bit darker here. 3x cubed is also a monomial. But what about 1? I'm giving this as an example, and 1 would really be 1x to the 0 power, and anything to the 0 power is 1, so 1x to the 0 power. And notice we said it was a non-negative power, okay? So 1 is actually a monomial. 2 is. Any integer is a monomial. Things that are not examples of monomials. 2x to the negative 1, okay? That has a negative power here. Negative 1 is a power that disqualifies this from being a monomial. How about 4x to the 3 halves? Okay. Now, we need an integer in our exponent. We can't have a fraction. And so that disqualifies 4x to the 3 halves from being a monomial or participating in anything that is classified as being a polynomial. Now let's talk about the terms of a polynomial. Polynomials are made up of one or more monomials, which are called terms. Okay? And when we're looking at monomials strung together to make a polynomial, we might see something like 2x squared minus 3x plus 4. Okay? And in this, we have three terms, 2x squared, negative 3x, and positive 4. And the way you can identify terms is that anytime you run into a plus or minus sign, you've just ended a term. So when we say that 2x squared ends with a squared, that's because we run into a minus sign. That's our cue that we've ended a term. When we run into another plus sign, that helps divide negative 3x into its own term. So terms are things that are added and subtracted together. And they form polynomials. Okay. Now let's talk about another type of polynomial, and this is a binomial. And a binomial has two terms in it. So if we look at these examples down here, 2x plus 1, we have the term 2x, and we also have the term positive 1. And because there's two terms in this polynomial, it is called a binomial. Also, 3x squared minus 4x is a binomial. This example I gave up here is not a binomial. It has three terms, 2x squared minus 3x plus 4. Now what we do know is that the example I gave before that I said was not a binomial is actually called a trinomial. Tri means three, And it's a 3-term polynomial, so 2x cubed plus 5x minus 2 would be a trinomial. And if we're looking to divide this trinomial into its 3 terms, we can see that 2x cubed is a term, positive 5x is a term, and negative 2 is a term. Likewise, with x squared plus 2x plus 3, x squared is a term, positive 2x is a term, and positive 3 is a term. Now let's talk about a coefficient. This is a very important term in algebra. A coefficient is a numerical or constant factor in an algebraic term. So in the term 3xyz, the coefficient is 3. Now, I've included some information here about what coefficient means. It's from the 1660s. It was probably introduced by Francois Viet, and co from the Latin means together. So the coefficient is always together with other factors, okay? And if you want to look more about this, I will post this PowerPoint online, and you can click on these links to see more about coefficients. But it's very important that we realize that, let's say we have this term 2x cubed. The coefficient of 2x cubed is 2. The coefficient of the positive 5x term is 5. The coefficient of negative 2 is negative 2. Because remember, this is negative 2 times x to the 0 power. Okay? Let's talk about the degree of a polynomial next. The degree of a polynomial is the highest power in the polynomial, and it's known as, sometimes called its order, okay? And again, there's more links here that you can take to Math World and other places to look and see more about degree. But degree really comes into play a lot when you get to the higher levels of mathematics, because we need some way to classify these polynomials. So look at this polynomial here, 2x squared plus 3x plus 1. The highest power in the polynomial is 2. So this polynomial has a degree of 2. Now, when a polynomial has multiple variables in its terms, the degree is the sum of the exponents of those variables. So look here, we have 2x cubed y squared plus 2xy minus 1. And if we look at this first term here, we see that x cubed plus y squared, or times y squared, is going to have a degree of 5 because we add these exponents together to get the degree, okay? And now when we're writing about polynomials, we're always going to put the highest degree to the left and then work our way down. A lot of people also like to organize them alphabetically with x's coming before y's and such. So let's name the degree of this polynomial. This first one, this would have a degree of 2. Where this next one, 7x squared plus y to the 4th, would have a degree of 6. Now here we have a polynomial with how many terms? We have 1, 2, 3, 4, 5 terms, and we have to choose the one with the highest exponent to be the degree of the polynomial, and that would be this 8x to the 4th term. So this would have a 4th degree classification. Okay. Now what about this, 1/2? Remember I said 1/2 is like saying 1/2 x to the 0 power. So this is a 0 degree polynomial, actually a monomial. Now let's talk about some other facts and notation. 2 polynomials are considered equivalent if you can transform one into another with basic mathematical properties. Okay? An identity. An identity is a statement that 2 polynomials are equivalent. For example, x times x minus 1. If we multiply x times x, we get x squared. And x times negative 1 gives me negative x. So therefore, the left is identical to the right, and we call it an identity. Now, think back to Algebra 1. What types of solutions do identities result in? If you remember, identities result in solutions where any real number can suffice, okay, because the 2 expressions are different. So if two polynomials are equivalent, they define equal functions that produce the same output for identical inputs. Therefore, all numbers are the solution. Now let's talk about the normal form of a polynomial. We typically write functions from the highest degree to the lowest degree in an alphabetical order. And the normal form is the form after applying all your basic math properties to the function. So we have f of x equals x minus 2 times x minus 1. Well, we would have to multiply these two binomials together and apply our distributive property in order to put it in its normal form, which should be x squared minus 3x plus 2. Now let's talk about the zero product property. If we have two numbers multiplied together, and we know their product is 0, then let's think about this. Shouldn't one of them be 0? Because the only way you can multiply two numbers together and get 0 is if one or both of them are 0. And this property comes in very handy for solving quadratic equations or any other equations. So if we take x squared minus 5x plus 6, and we know that its equivalent expression is x minus 2 times x minus 3 equals 0, then I have that x minus 2 equals 0, or x minus 3 equals 0. And here I have expressed those equations. So solving those two equations yields that x must equal 2 or 3, and my solution set then contains two solutions for x, not just one. When we're multiplying polynomials, we're going to apply the distributive property. And this is a property that we use over and over and over. So if I say a times b plus c, that means a times b plus a times c. Okay? And what this might look like is x times x minus 3. That would be x times x, which is equal to x squared, and x times negative 3, which is negative 3x. Here's another example with multiplying two binomials together. And the way I like to do this is to take the first term of the leftmost binomial, or leftmost term, and multiply it by the first term of the right. So x times x becomes x squared. And then I take the first of the left and multiply it by the second of the right. And I just work my way across until I've multiplied this first term in the first binomial of x plus 7 by every single term in the other binomial. What I get when I do that multiplication is negative 5x. Now I take the second term of my first binomial, 7, and I multiply it by each of the terms in the other binomial, and I get 7x minus 35. Now when I look at this, I have two x terms that I can combine. Negative 5x and positive 7 leave me with a positive 2x. And my other terms have nothing to combine with, so I'm just going to bring them on down. So my resulting polynomial is a three-term polynomial, x squared minus 2x, or plus 2x minus 35. Here's another example of how to multiply polynomials. Again, I'm going to multiply this first x by each of the terms in that second polynomial. So x times 2x squared should give me 2x cubed. X times 3x should give me 3x squared. And x times 4, or negative 4, should give me negative 4x. Now what I would like to do is multiply negative 1 by each of the terms, which is going to give me negative 2x squared minus 3x plus 4. Now if I look at this, I really should have kept the black ink the same. I've got two terms here that I can combine. I've got two terms here that I can combine, and I'm going to put different shapes around them so that you can see which ones I'm combining. So I'll end up with 2x cubed plus x squared minus 7x plus 4. And I got this by combining this, and this by combining those. So take a look at that and make sure you understand that and can do it with me. Now let's take a look at a different method, and we call this method the box method. And for very visual people, this method sometimes works very well. And what I do is I take one polynomial, x minus 3, and I list its individual terms down one side of my box. And I take this other polynomial, x plus 8, and I list its terms across in my box. And then I multiply the two terms. So x times x gives me x squared. X times 8 gives me 8x. X times negative 3 gives me negative 3x. And negative 3 times 8 gives me negative 24. And then I can combine the terms on the diagonal. So I'm left with x squared. 8x and negative 3x give me positive 5x minus 24. Okay? And you can do this with any size polynomial. It really works quite well. Let's try this with a larger polynomial. Here we have x plus 2. So my terms down the left will be x and 2. And x squared plus 3x plus 2, my terms will be x squared, 3x, and 2. When I multiply this, I get x cubed, 3x squared, 2x, 2x squared, 6x, and 4. And you can see the ones on the diagonal also combine. So I'm left with x cubed plus and 3x cubed and 3x squared and 2x squared give me 5x squared. 2x and 6x give me 8x and 4. So that allows me to multiply these very nicely. This is going to be the end of our lesson for today. Come to class having watched this and being comfortable with how to do these problems, because we're going to do a lot of them in class. We'll see you later. Bye.